Hello, my fellow mathematician. Welcome to Calculus 2. And we are looking at integrals of inverse trigonometric function. In today's video, we will be focusing on how to integrate cos inverse of x. And we are going to see that the result is cos inverse of x multiplied by x minus square root of 1 minus x squared plus a constant c. We are going to make use of what is called integration by part, whereby you have function u. Our function u is cos inverse of x, and our function v prime is dx, which is equal to u multiplied by v. Our v is x, this one, and our u is cos inverse of x minus. So we are going to see now how minus integral of u prime is this one here, then multiplied by v. So to begin with, we are going to write cos inverse of x dx. So cos inverse of x multiplied by dx is equal to our v is x, is equal to x multiplied by, now our u is cos inverse of x multiplied by cos inverse of x multiplied by cos inverse of x minus integral of our v prime is dx, minus our v is x minus x dx divided by our u prime is this one. Now cos when you differentiate cos inverse of x, we will get -1 divided by square root of 1 minus x squared. Now to know how we arrive with the u prime being equal to -1 over square root of 1 minus x squared, you can check in my YouTube channel at Look Aaron 1, and you are going to see how we obtain that value in a simple method step, what we are going to see. So this is a square root of 1 minus x squared, this one there, x squared. Now v prime is dx, so how are we obtaining x here? Integral of v prime is v, integral of dx is x here, taking integral both sides. Integral of v prime will give you v, and the integral of x will give you x. So the focus now is to integrate this part here. Remember, when you are substituting to include this negative here, there is that negative there. So we want to integrate this part, x dx square root divided by square root of 1 minus x squared. So this part here will be done by letting, we are going to let our u to be equal to the denominator, what is inside the square root of the denominator, which is 1 minus x squared. Then we differentiate, du will be equal to negative. When you differentiate x squared, it will give you negative 2x dx. Then from there, you divide both sides by -2. So du divided by -2 will give you, you will be left with the x dx. Then you come here and you substitute. Instead of x dx, you are going to write negative 1 over 2 du divided by, instead of 1 minus x squared, you are going to write u, and because it is square root, power half is the same as square root. Using the laws of indices, you can take u up. When you take u up, the index will be negative half du. So this is negative half du. Now, integrating by power rule, what you are going to do, we are going to add 1. So you have, we can do it aside here. You have power negative half plus 1. This is the same as u power negative 1 over 1 plus LCM is 2. So 2 divided by 2 is 1. 1 times negative 1 will give you negative 1. 2 divided by 1 here, it will give you 2. 2 times 2. 2 times 1, sorry, will give you 2. So negative 1 plus 2 is 1 over 2. So the result here will be half multiplied by 2 over 1 u power half u power half plus constant c. Remember, there is this negative outside. There is negative. This is equal to, this one will cancel and you will have negative u power half plus c, which can be written as negative integral of, our u was 1 minus x squared plus constant c. So now, meaning that integral of x dx over 1 minus x squared is the same as negative integral of 1 minus x squared plus constant c. Now remember, our objective was to integrate cos inverse of x. So this is the part we have found there. So the final result will be, so we are going to combine this part and this other part here. So integral of cos inverse of x dx will be given by x here, this one, x cos inverse of x minus square root of this other part here which we have found, minus square root of 1 minus x squared plus constant c. So to do this, it appears to be a bit lengthy, but provided you know how to integrate by part and you have knowledge of calculus 1, which is differential calculus, that when you differentiate cos inverse of x, the result is negative 1 divided by square root of 1 minus x, and you know how to integrate simple integrals, then it becomes simple. And also, it is testing the knowledge of integration by use substitution. Now, this symbol here, minus and minus, will be positive. So that is why now, when we come to the final result here, we have this part here being negative, because when we integrate x dx over square root of 1 minus x squared, it is giving us negative of 1 minus x squared, as shown here. So thanks so much for taking time to study with me calculus 2, and particularly on integration of inverse trigonometric function. For other integrals of inverse trigonometric function, you can check in my YouTube channel, and you are going to obtain the result in a simple step method. Thanks, bye bye, see you in the next video. Remember to like and also to subscribe to this channel and to share with other mathematicians so that we may continue learning together.